Okay, to warm up for today, I'd like you to consider the following problem. Farmer Bob wants to build a rectangular chicken coop. He has 20 feet of chicken wire to use. Use the table to model the area as a function of the length and width of the chicken coop. What features do you notice about the data, and what dimensions would give him the largest area? Pause the video and try to fill this table out now. All right, let's see how you did. So here's the data that you should have come up with. So if the length of the chicken coop is 1 foot long, then the width would have to be 9 feet long. If the chicken coop is rectangular, we can see that the perimeter would be 2 times the length plus 2 times the width. 2 times 1 is 2, 2 times 9 is 18, for a total of a perimeter of 20 feet. And as stated in the problem, he only has 20 feet of chicken wire to use. Now with these dimensions, the area would be 9 square feet. 1 times 9 is 9. Now if the length is 2 feet long, then the width would have to be 8 feet long. 2 times 2 is 4, 2 times 8 is 16, and 16 plus 4 is a total of 20 feet for the perimeter. And of course, the area of the chicken coop at this point would be 16 feet squared, because 8 feet times 2 feet would be 16 feet. And so on and so on. And I hope you notice that there's a pattern here. As one side increases, the other side decreases. And so if we have a length of x, then the width would have to be 10 minus x. Now let's see if that works out. All right? If the length is 1, then the width would have to be 10 minus 1. If the length is 2, then the width would have to be 10 minus 2, and so on, and so on, and so on. And so if this is the case, then the area would have to be the length times the width, and x times 10 minus x is 10x minus x squared. Now, you don't have graph paper in front of you, so I'm just going to show you how this would be done, but the task is graph the function for the area of the chicken coop, ax equals negative x squared plus 10x. Let x be the length in feet, and ax be the area in square feet. So essentially, our x in this case is the length, and our a of x, or the output, is the area. So based on the length of one side of the chicken coop, what would the area be of the whole chicken coop? And if we graph this data, notice what happens. All right? And we can notice this in the data too. So a few things. There's no constant rate of change here. The difference between 9 and 16 is 7, but between 16 and 21 is only 5. And then between 21 and 24 is only 3, and then we increase by 1. And then if you notice, we start to decrease by those same values in opposite order. And this is reflected in the graph. Here we have our data points. They're going up, but they're kind of slowing down, and they reach this maximum point, and then they start to descend. Something else you should notice is that this maximum point represents the largest area. And so the answer to one of the questions on the other slide was, what would give Farmer Bob, I think it was, the maximum area? Well, that would be dimensions of 5 feet for the length and 5 feet for the width, for a maximum area of 25 feet. Now, this is a special type of function called a quadratic function. And quadratic functions, when graphed, have this funny little shape, looks like a U, and this is called a parabola. It is a U-shaped graph. And there are some key features of a parabola that you need to be aware of. All right, first feature are the zeros, or the x-intercepts of the function. Now we know about x-intercepts. X-intercepts are where the function crosses the x-axis. Or another way of thinking about them is the value of x when the output is 0, which is why they're called zeros. And because quadratic functions involved taking the variable, or taking the input and squaring it, To solve quadratic functions involve taking square roots, so these points, or these data points, are sometimes called the roots of the function. Some other features are the y-intercept, the value of y when x is 0, the vertex, or where the two sides of the parabola meet, and what's called the axis or line of symmetry. And this line cuts the graph in half. All right, and if you recall symmetry from 7th grade, a figure is symmetrical if one side is a mirror image of the other side. And so if you can imagine folding this graph along this line, the left side would fold over and meet or fold right on top of the right side. This line of symmetry becomes very, very important when later on when we want to find the vertex. To introduce you to quadratic functions, I would like you to take these 3 quadratic functions and generate data for each by just plugging in values for x and finding values for y. So plug in a value for x here, and evaluate and find a value for y. Do that for the second function and the third function. All right, pause the video now and accomplish that task. All right, let's see how you did. So you should have gotten the same data for all 3. All right, and why? Because they're all the same function, but they're written in different forms. So y equals x squared plus 7x plus 10 can be rearranged to look like y equals x plus 2 times x plus 5. This should be very familiar because this form is just the factored form of this trinomial, x squared plus 7x plus 10. And this other form, we're going to learn about this form a little later on. This is less intuitive. But the takeaway here is quadratic equations can be rearranged, all right, in different forms, and each form has a purpose. So let's explore that purpose now. So the main 3 forms of quadratic equations are thus. The first one is called standard form or expanded form. All right, it's y equals a times x squared plus b times x plus c, where a represents the coefficient of your variable squared, b represents the coefficient of your variable, and c is the constant, the term that does not depend on the value of the input variable. Vertex form is y equals a times x minus h squared plus k, where a is the coefficient of x squared in standard form. So really all you need to know is this value right over here, a, is the same value over here in standard form. This value becomes very, very important later on when we begin to explore transformations of quadratic functions, but you don't need to worry about that right now. All you need to know is this a is the same as that a. Now h, this value right here, all right, represents the x-coordinate of the vertex, and k, this value over here, represents the y-coordinate of the vertex. And finally, intercept or factored form is y equals a times x minus p times x minus q. And as you might guess, a represents the same value as the a in vertex form and the a in standard form. And the values of p and q represent each of the 2 x-intercepts or zeros or roots of the function. So let's take a look at expanded form. One of the things you're going to need to do is interpret each form to get some useful information from each of them. So in expanded form, we have a value a, b, and c. Here are 4 equations in standard form. I would like you to identify the values of a, b, and c in each. So pause the video and identify those values now. All right, let's see how you did. So in the first equation, all right, the value of a is 2, the value of b, the coefficient of x, is 3, and the constant is 4. So a equals 2, b equals 3, c equals 4. In our second quadratic equation, the value of a is negative 6, the coefficient of x squared, The value of b, the coefficient of x, is 4, and our constant is negative 9. In the third equation, the coefficient of x squared is 10, the coefficient of x is negative 14, and our constant is 7. And in the last one, the coefficient of x squared is negative 8, the coefficient of x is negative 5, and our constant is negative 13. Now, these four equations were really, really simple and straightforward. I'd like to present to you these equations. Try to identify the values of a, b, and c in each of these equations. Pause the video and attempt that now. All right, let's see how you did. Now, you might have noticed in the first equation that we don't have three terms. Standard form has three terms, so what are we supposed to do? Well, if you notice, what's the definition of each value? A is the coefficient of x squared. Well, the coefficient of x squared here is 8. All right? C is the constant, and here we have a constant. What we don't have is a coefficient of x. That term isn't written here. So what value of b could represent a term bx that isn't written? As you might have guessed, if we reinterpret this as 8x squared plus 0 times x plus 5 equals y, all right, we can clearly see the value of b. If the value of b is 0, then our middle term is 0x, which means the product would be 0, and that means we don't have to write it in our expression. So the value of a is 8, the value of b is 0, and the value of c is 5. Now, let's move on to this next one. If you had trouble with this before, I'm sure you've guessed what the values of b and c are now. So a is the coefficient of x squared, but we don't really have values for b and c. So what do you think they might be? Yep, we have to reinterpret those values as being 0. Negative 3x squared plus 0 times x plus 0. If you will recall from linear equations, when we had a y-intercept of 0, we didn't write mx plus 0. We just wrote the slope and the variable, and that's it. Because you never have to write plus 0, and you never have to write multiplication by 0. So the values of a, b, and c are negative 3, 0, and 0. Now, this third one, you might be tempted to say that the coefficient of x squared is 0, the coefficient of the coefficient of x is 5, and the constant is 7. However, you'd be wrong, because even though you're looking or analyzing this as a quadratic equation, it's not. Quadratic equations always involve squaring the variable. This does not square the variable, so it's not a quadratic equation. It's a linear equation, so we don't need to interpret it as a quadratic. And then finally, this last equation seems a little bit more complicated than the rest. All right, the key idea here is this equation is not in standard form. So if it's not in standard form, all right, we can't interpret it as standard form yet. So if you said that the coefficient of x squared was 7, the coefficient of x was 5, and the constant was 20, you'd be kind of wrong because it's not in standard form. So we first need to get it into standard form by subtracting 6 from both sides, and now we can interpret it as standard form. So the values of a, b, and c are 7, 5, and 14. Now, let's take a look at vertex form. Vertex form is where a is outside of the parentheses. Then we have x minus h, where h is the x-coordinate of the vertex. Now notice, h comes after the subtraction sign. Now, I know I've told you that you shouldn't look at these signs as subtraction signs, and that's fine. If you want to look at this as being the opposite of h, that's fine too. But because we're analyzing forms here, I like to focus on the symbols in the form. So if the symbols say open parentheses x and then a minus sign and then an h, all right, I want to interpret that form as x minus sign h, where h is the value that comes after the minus or negative sign. And then outside the parentheses, we have this constant k, which is the y-coordinate of the vertex. So what I'd like you to do is look at these four equations in vertex form and see if you can identify the value of a and the vertex for these quadratic functions. So pause the video now. All right, let's see how you did. So in the first one, the value of a is going to be outside the parentheses here, and that's going to be 3. The value of h, like I said, comes after the negative sign or the subtraction sign, so this reads x minus and then 4. So 4 would be the x-coordinate of our vertex, and then, of course, we have a positive 5 on the outside of the parentheses. And so the value of a is 3, and the vertex is 4, 5. For the next one, all right, the value of a is outside here in the parentheses. Well, what's outside of the parentheses here? Do you see anything? I sure do. All right, what did I say was always outside of parentheses? There's a 1. All right, so the value of a is going to be 1. All right, the value of h is going to be positive 8 because h comes after the negative or subtraction sign. And the constant out here is going to be negative 7. So the value of a is 1, and the vertex is 8, negative 7. All right, for our next one, we have a negative sign outside of the parentheses, which represents negative 1. The value of h is going to be positive 5/9 because it comes after the negative or subtraction sign. And outside the parentheses, we have a positive 2/3. So the value of a is negative 1, and the vertex is 5/9 and 2/3. And then last but not least, we have this equation. Now, if you notice, there's something different about this vertex form. Here we had x minus something. Here we had x minus something. Here we had x minus something. This does not have an x minus something. All right, so there's two ways of looking at this. First, we can reinterpret this as x minus something. So every addition problem can be reinterpreted as a subtraction problem. So remember, addition is equivalent to the subtraction of negative value, or the opposite of adding negative value. So this could be read as x minus negative 12. Looking at it this way, the x-coordinate of our vertex is negative 12, and the y-coordinate is negative 18. And of course, the value of a is pretty simple or easy to identify here. It's negative 4/9. So a is negative 4/9, and the vertex is negative 12, negative 18. And our last form is intercept or factored form, all right, where a is the coefficient of x squared, and p and q represent our intercepts, roots, or zeros of the function. Now, notice this form. All right, we need an a on the outside here. All right, then the first factor reads x minus p, and the second factor reads x minus q. So keep that in mind when trying to interpret factored or intercept form. All right, try to identify the value of a and the two zeros or x-intercepts or roots of each of these quadratic functions. Pause the video and try to accomplish that now. All right, let's see how you did. So for the first one, all right, we have an outside term of what? What's the value of a here? Well, it's the invisible 1. Here we have x minus, and the value of p comes after the minus sign. So the first 0 is going to be 5, and the second 0 here is going to be 6. And if you think about it, what value could we plug in here that would make this first factor 0? Well, if we plugged in a 5, 5 minus 5 would equal 0, and then it really wouldn't matter what this factor would be because the product would be 0. So out comes a 0. So the value of a is equal to 1, and the zeros are 5 and 6. All right, for the second one, all right, the outside term is 3, so the value of a is 3. Now here we have x plus 7. Now like I said, all right, if you want to strictly interpret it according to its form, you need to reinterpret this addition problem as a subtraction problem. So x plus 7 could be thought of as x minus negative 7. All right, so one of the zeros is going to be negative 7, and over here, the other 0 is going to be 2. Another way of thinking about this, like I said, if you don't want to think of this as a subtraction sign and you're used to thinking of them as negative signs, well, then this just means that the first zero is the opposite of P and the second zero is the opposite of Q. So here we have a 7, so what's the opposite of 7? Negative 7. Here we have a negative 2, what's the opposite of negative 2? Positive 2. So the two zeros here are negative 7 and 2, and the value of A is 3. Over here, we have y equals negative 2x minus 6 times x plus 9. Now, notice, this first factor does not read x minus p. It's 2x minus something. So we need to fix that. The way to fix that is to factor out this 2 so we have just an x, or a coefficient of 1. So when we factor out that 2, all right, what we get is factored form. So the value of A is going to be negative 2, and our two zeros are going to be positive 3 and positive 9, or the opposite of negative 3 and negative 9. So A equals negative 2, and the zeros are 3 and 9. All right, now this last one, if you notice, both factors aren't in the form of x minus something. So we're going to have to factor out this leading coefficient. So the first thing we need to do is factor out a 3 for the first factor, all right, and factor out a 4 for the second factor. Now we're left with x minus 8/3 and x plus 2. Now, simplifying this, all right, we're going to multiply the 3 and 4, and so what we get is 12 times x minus 8/3 times x minus negative 2. So the value of A is 12, and our two zeros are positive 8/3 and negative 2.